All right, hey, welcome. So this is lesson 2-2 for Algebra 2. This is linear relations and functions. Okay. And we're going to talk about lines and different types of relations, and I'm going to give you some examples so that you can understand that. A little bit off again. Hang on, there we go, that's pretty good. So a linear relation is a relation whose graph forms a line. Hence the word line in the word linear. So when you see that linear, you should be thinking to yourself line. So these are relations whose graphs form straight lines. So here's an example, just sketched out, not drawn to scale, but there's my x-axis, there's my y-axis. Here's an example of what would be a linear relation. Or it could look like this. My x and my y, and here's my line. Okay, these are both examples of linear relations. Written out algebraically might look like this. 4x minus 2y equals 10. That's an example of a linear relation. X equals 3. Y equals 1. Y equals 1/2 x. These are all examples of linear relations. Okay. Now, non-linear relations are relations whose graphs are not straight lines. And these could look like this. Okay, here's my x and here's my y. It could look like this. This one happens to be quadratic. Okay. Or it could look like this. And these are just examples. These we'll get into later. It could look something like this. Again, just a sketch. This is trigonomic. Okay. And algebraically, they might look like this. And my last one, put over here. Now, between this group of equations and this one, what do you notice? What do you see that's different? Because the difference is what makes one linear and the other one nonlinear. So nonlinear equations will have exponents. Okay. Or they'll have a radical. Or we'll have two of the same variable, x and xy here. Or your variable will be in your denominator. Your x will be in your denominator. These are all examples of nonlinear relations. And the reason it's important to kind of know that is that when you're asked to graph, and I'm asking you to graph something linear, and you graph something that looks like this, well, you have to recognize that you're not graphing correctly. So please make sure you're familiar with what linear equations look like and nonlinear equations look like. Because you will be asked to identify linear equations. And here's what I mean. Might give you this. F of x equals 8 minus 3/4 x. You would tell me, is this linear or not? Well, remember, this is the same thing as y, so it doesn't play. Then this x can go to the 3, so it's not in my denominator. So hopefully you would recognize that this is linear. Okay, here's another example. F of x equals 2 over x. Well, hopefully from my previous example here, you see there's an x in the denominator, which means this problem is not linear. And how about this one? If you said yes, you'd be correct. That one is linear. So again, I'm going to be asking you to identify these in the homework and on a quiz. So make sure you know the difference, and if you don't, please ask. Now, when we evaluate linear functions, like we did with relations, I give you something to plug in, a number to plug in, and you substitute it in for x, and then simplify using the order of operations. So evaluating linear functions, you've got f of x equals 6x plus 23. And I want to evaluate that for when x equals 3. So here where I see an x, I'm going to put 3. And I'm going to simplify using the order of operations. This is 18 plus 23, which is 41. Okay. Another example. Okay, so where I see an x, I'm going to put the 8. So I've got f of x equals 1/2 times 8 plus 4. Well, 1/2 times 8 is 4, and 4 plus 4 is 8. Okay. So that's how you evaluate. Now the next part of this lesson is what we call standard form of a linear equation. It's important that you know this. We'll be working with this quite a bit, a little bit later in this chapter. So standard form of a linear equation is written in the form ax plus by equals c, where a, b, and c are all integers. And if you don't remember what that is, I'm going to encourage you to look that up. So all integers greater than 1, and absolutely no fractions. So if you have something written with fractions and you need to put it in standard form, you're going to have to get rid of the fractions, but also no decimals. So here's an example. I've got negative 1/2 x plus 5y equals 40. Well, in a standard form equation, our lead coefficient is generally positive. So I need to, 1, get rid of this fraction, and 2, I want to make this positive. So to do that, if I multiply everything by -2, I will get rid of this fraction and this negative. When I do, this -2 and this -2 cancel each other out, and that leaves me 1x. -2 times 5y is -10y. -2 times 40 is -80. So as you can see, my x's and y's are on the same side of the equal sign, and it equals a constant. So this is standard form. Let's look at another one. Start with an easy one. On this one, if you notice, I've got a y on one side of the equal sign and an x on the other. Well, to be in standard form, the x and the y have to be on the same side of the equal sign. So what I'm going to do is I'm going to add 2x to both sides. These cancel, and that's going to leave me 2x plus 3y equals 4. Now, please don't make the mistake and think you can add these two things together. You cannot. They are not like terms. So now this one is in standard form. Do one more. 2/7 x plus 2/3 y equals 4. Okay, so here I've got fractions and I need to get rid of them. I need to multiply everything by the common denominator. If you can't figure that out by looking at it, you can multiply your denominators together. 7 times 3 is 21. And then multiply all three terms by that. That will clear those fractions out so we can get this in true standard form. 7 goes into 21 3 times. That's going to leave me 3 times 2, which is 6x. 3 goes into 21 7 times, so that's going to leave me 7 times 2, which is 14, leaving me 14y. And 21 times 4 is 84. So here is the standard form of that equation. Okay. If you have questions on this, please email me, but that's our lesson for the day. Thank you.